we were dealing with R is equal to V by I. That is our third equation. Okay, R is equal to V by I. R, we studied that R is resistance. Okay, a constant which is resistance. And how we got this? By plotting V by I graph. Okay, in that we understood that when we check the reading in V and a voltmeter and ammeter, we got a point in the graph. Okay, and when we are drawing one line from origin O, we got a straight line. So we concluded that it is a constant. That constant is called resistance. Resistance is the property of the conductor to resist the charges passing through it. And we studied that its SI unit is ohm and it is represented by the Greek letter. Okay, some Greek letter we have studied. Then, if the potential difference across the conductor is 1 volt and the current passing through it is 1 ampere, then the resistance through it, the resistance of the conductor is 1 ohm. Okay, when the potential difference between two ends of a conductor is 1 V and the current passing through it is 1 A, then the resistance of the conductor is 1 ohm. Okay, resistance is 1 ohm. We will write that 1 ohm is equal to 1 volt by 1 ampere. 1 volt by 1 ampere. Okay, 1 ohm is equal to, that is resistance is equal to potential difference by current. And from the above equation, from equation 2, we get, what is equation 2? Equation 2 is V is equal to IR. Okay, V is equal to IR, and from this equation we will get I is equal to V by R. Okay, the current I is equal to V by R, which is the fourth equation. From this equation, what we can observe? The current flowing through a resistor. The current flowing through a resistor is inversely proportional. Okay, the current flowing through a resistor is inversely proportional to its resistance. Okay, the current flowing through a resistor is inversely proportional to its resistance. If the resistance is doubled, the current flowing through it is halved. Okay, when the resistance is doubled, what happens? The current flowing through it become halved. Okay, when the resisting is the current, what is the duty, or what the resistor does or resistance does? It will resist the current or charges passing through it. When resistance doubled, what happened? The current is halved. Okay, so in some cases it is necessary to increase and decrease the current in electric circuit. Okay, if you observe some circuit, we can understand that in some case we want to increase and decrease electric circuit. We want to increase and decrease electric current in an electric circuit, and increase and decrease electric current in an electric circuit. Did you heard about variable resistance? Variable resistance. A component used to regulate current without changing the voltage source. A component used to regulate current without changing the voltage source. Okay. It is a component used to regulate current without changing the voltage source. Okay. Then did you heard about rheostat? Rheostat. Did you heard about rheostat? Rheostat is often used in an electric circuit to change the resistance. Okay. Rheostat is used in electric circuit for changing the resistance. And let us go back to Ohm's law. The potential difference across a metallic wire and the current flowing through that is directly proportional. Okay. What George Simon Ohm stated that the potential difference of the wires and the current in both ends are directly proportional. So that we got the equation V directly proportional to I. Okay. Then after plotting one graph we got V by I. Okay. We understood that it is a constant. And this constant is R. Okay. This constant is R or resistance. Okay. What is resistance? The property of a material to resist the charge flowing through it. Then potential difference V is equal to IR. Okay. I into R. Current into resistance. That is equation 2. Then resistance. How to find resistance? R is equal to V by I. Okay. V by I. R is equal to V by I. Then R is equal to V by I. Then that is, in other words, we can say 1 ohm is equal to 1 volt by current. Okay. 1 volt by current, which is in ampere. Okay. And I, for finding I is equal to V by R. Okay. Volt by resistance. And we can say this is the current flowing through a resistor is inversely proportional to the resistance. And these are some important formulas. Okay. V directly proportional to I. That indicates Ohm's law. Okay. Then V by I is equal to R. Volt is equal to current into resistance. And resistance is equal to V by I. And current is equal to V by R. And please note it like this. And this is all we have for today. And if you give little time to study, it will be good for your future. Thank you. And we will meet in next class with another topic. Good morning, my dear students. Welcome to Science Classroom. So, in science, we are in physics and also we are studying chapter 12, which is dealing with electricity. We studied potential difference, and last class we studied an activity to study Ohm's law. So the activity was about connecting the different cells. Okay, first we are connecting in the activity there is voltmeter, ammeter, resistance, then four cells are there, and it is connected, and we have to check one by one by adding one by one cell in the circuit. First we are checking the voltmeter reading and ammeter reading using what? Adding first we are connecting one cell and we are checking the voltmeter and ammeter reading. Again we are doing the same, adding one more cell and checking the voltmeter and ammeter reading. Again we are adding one more battery or cell. Then we are checking the voltmeter and ammeter reading. We are noting it. And then for example, we have noted some points, and in the finally also we are adding one cell and we are checking the voltmeter and ammeter reading. Did you got that? So in that, according to that, we plotted one graph. Okay, we plotted one graph which is V by I graph. Okay, in it current I, which is the ammeter reading, and potential difference V in voltmeter. Okay, in voltmeter we checked and some readings are there, and on that we plotted one graph. Okay, in that we got some points, 4 points like this, and from the point of origin O, if we draw a straight line, it touches all the points which we got in different readings. Okay, we will obtain a graph like this, which is if we draw a line from the point of origin O, then it will pass through all the points of intersection between the V by I. So we can say V by I is in constant ratio. We can say that V by I is in constant ratio, because it will both V and I meet at a point. In different cases, all the cases it meet at a point, and if we draw a line from origin, it pass through it. Okay, so we can say V by I is a constant ratio. Then did you heard about George Simon Ohm? George Simon Ohm. George Simon Ohm. George Simon Ohm. Okay, we are studying Ohm's law. So you will definitely think that this person may have given some contribution for this. So let us see who is that. He is a German physicist. Okay, he is a German physicist. He found the relationship between potential difference. Okay, potential difference through a metallic wire and the current. Okay, and the current in both terminals. Okay, potential difference of the wire and the current in both terminals. So what is his findings? Once again I'll say George Simon Ohm is German physicist who found the relationship between potential difference in a wire and the current in different terminals. Okay, from positive terminal to negative terminal, if it is moving, then he find the potential difference in the wire and the current in each terminal. So, what are his findings? His findings were this: the potential difference V across the end of a given metallic wire is directly proportional to the current flowing through it. Okay, the potential difference V flowing through a metallic wire is directly proportional to the current flowing through it. Okay, what was his findings? The potential difference V in a metallic wire is directly proportional to the current flowing through it. And he also found that the temperature is same. Okay, he also found that the temperature is same. So we can say that Ohm's law. What is Ohm's law? How we can define Ohm's law? The current flowing, the potential difference across a conductor is directly proportional to the current flowing through it. We can Ohm's law, we can write that the potential difference V in a metallic wire or in a conductor is directly proportional to the current flowing through it. Okay, we can take it as equation number 1. Then V by I is constant. V by I is constant. We have plotted the values V by I graph. In that we got a constant. If we go further, we will again get we have drawn the straight line from the origin till the end. So we studied that V by I is a constant. So I wrote here V by I is equal to is constant. Okay, and this constant is called R. V by I, the constant is called R. Then how we can find V? The potential difference V is equal to I R. I into R, current into this R is nothing but this is the resistance. Okay, R is in this equation. R is the constant, that is nothing but it is the resistance. Okay, and what is resistance? Okay, what is resistance? Let us study what is resistance. Resistance is the property of a conductor to resist the flow of charges. To resist the flow of charges. Okay. The property of a conductor to resist the flow of charges. Resist means give some opposite force or just give a opposite or stop there. Okay. The property of a conductor to resist the flow of charges. And the SI unit is ohm. Okay, which is denoted by the Greek letter ohm. Somewhat some more difference is there, which is Greek letter ohm. Okay, which is represented by the Greek letter ohm. According to Ohm's law, resistance. According to Ohm's law, resistance resistance R is equal to V by I. Okay, resistance is equal to V by I. We have plotted the graph. Okay, in that we got a constant. That constant is what? Resistance. Okay, and that resistance is equal to, how we are getting? By plotting the graph of potential difference by current flowing through it. Okay, so the resistance R is equal to V by I. So this is the third. Then